Hi everyone, welcome to Recitation for Module 5. So today we'll be recapping what was discussed in lecture about methods. And so this will include why we would want to use methods in our code, what makes up a method, so like the anatomy of a method, the call stack, which kind of um, determines what order different pieces of your code are executed in, and how different pieces of code work together with methods. And then lastly, overriding methods, which we'll get more into later. So, Module 5, methods. I think it's really common for students to wonder, um, why do we have to do this? Our code was working fine before, and this isn't necessarily adding anything different than what you could do without methods. But what methods are really about is allowing us to take repetitive parts of code and put them in one place or neatly package them up where we can later reference them multiple times and just whenever we want to execute them. So that's kind of motivation for why we're learning methods and why methods are going to be such a big part of honestly just computer science in general. So, getting more into that, we'll talk about the concept of abstraction. And so, abstraction is wrapping code in a method so that someone else, or even yourself somewhere else down the line, can call your method without knowing exactly how it works. So, we kind of saw this with the standard draw library when we were using this library that someone else had created and looking at the documentation to know how to use it without knowing exactly how it's working behind the scenes. So whoever's using this method just needs to know the input or the parameters that the method needs and what kind of output to expect from the method. So, like I mentioned, some benefits of methods. They're easier to write, kind of more packaged up and separated from each other. They're easier to debug because you can, again, have that separation of different parts of your code that make it easier to see where something's going wrong. Easier to maintain, where if you have um, a repeated chunk of code that you're calling multiple times with a method, if you need to update one part of that and you need to update each time it's called, you just need to update the method once, and all the different times you call it will then be updated with that update of the method. They're easier to read, where instead of reading a whole big kind of verbose chunk of code, you might just see a method title or like a method name that's very descriptive, short, and just like one line. And overall, easier. So, we're big fans of methods. So, kind of to put it into perspective a little bit, let's say we're writing the Civ of Aristophanes. So this was one of our previous studios that was kind of involved with like nested loops to find prime numbers, right? So let's imagine a situation in which we want to write a program that does that process to find the prime numbers from 1 to 40, and then afterwards wants to find the prime numbers from 1 to 100. And then after that wants to find the prime numbers from 1 to 500. And maybe this program's trying to compare them or something like that, or have them have all of those printed out in three different places. But um, we could do, we could write that entire code chunk that we had three times, one for um, numbers 1 through 40, once through for numbers 1 through 100, and once for numbers 1 through 500. But as you'll remember, pretty complex code. You'll have the nested loops and like arrays to keep track of. And overall, that's going to be a pretty repetitive and inefficient way to write this program. So instead, what we could do is we could write a method where we have the sieve, and the parameter could be the number that you want to go up until. And then inside that method, then we would put all of the stuff that performs the sieve of Eratosthenes to find the prime numbers. So now in our actual program, instead of writing the entire process out 3 times, we can just write sieve with parameter 40, sieve with parameter 100, and sieve with parameter 500. And this would do the same thing, but it's much easier to read. There's less chance for error because you don't need to repeat that whole complicated code 3 times. And just overall, this is a much easier and cleaner way to write your code. So here we have a bit of an outline of what a method declaration will typically look like. Um, and so here we start with the access. So this will either be private or public. And if it's private, that means the method can only be called from within that file that you've declared it in. So maybe this is something that you're not needing to use across different files, or just something where you want to keep it contained and keep the access limited. Public, that means that method can be called from anywhere and it can be called by anyone. So like different files within your project can call it, and there won't be as much of a containerization of that. And then, so like for example, the example we have here is if we declare silly method as private in myjavafile.java, then you wouldn't be able to call that silly method in newfile.java. And you wouldn't be able to unless you changed that method to be public. And so what's the motivation for this? Um, it's later on going to be helpful for us to control who is able to call certain methods. Um, just in more complex things, you want to kind of control um, like the different aspects of your code. And then so the next part of our methods is this word static. And so for now, we're just going to keep that static there. And we're just going to keep that there until module 7. Um, or you can just leave out this modifier and write something where you just leave it out entirely. So like public string my method. Um, Again, for now, until we introduce objects in module 7, we're just going to assume that methods are static and include it in the method header. The next part of a method that we have is the return type. And so that's going to be the data type that is expected to be returned by this method. So let's say that we've made a method that we've called repeat word, and it takes in a string as its parameter and has a string as its return type. So if we try to say int reversed equals repeat word hello, that's not going to work because you're saying, when you say int reversed, you're saying that you are trying to store this as an integer, but repeat word we know will return a string based on what we've said about this method that we've written that has string as its return type. So this is going to get an error because we're trying to set an integer variable equal to be a string, which doesn't work. Next, we have the name of the method, and so that's just how you can reference it, how you can call it later on to execute it. Sort of counterintuitively, you can have more than one method with the same name, but there are really specific limitations to when you do this, and we'll come back to this later when we talk about overloading methods. Without having a method name, we wouldn't have an easy way to call a method, and so, I mean, you need some way to actually call this code and execute it, right? So, I think name is probably pretty self-explanatory. And then parameter type is similar to the return type in the way that it's specifying what data type is expected here. So for a parameter, you want to specify what type you expect because you are not going to declare that variable within your method. So you won't have your typical int x and then equals something because you're expecting that to already be passed in, so you're not setting it yourself. But because we don't have that declaration step, we need to have the type in the parameter. So A, the method knows what type of input to expect, and B, so that Java knows how to treat this variable that you have in the method. So just like we have the parameter type, we also need a parameter name so that we can reference this as a variable within the method. So what this will end up looking like is the parameter might look like int number, and that way later on in your method, you can reference this as number, and that will be the input that you've gotten as a parameter. Um, Not all methods will need parameters. Maybe you have a method that just does something without any input, like this example on the slide. So in that case, you don't need to put anything within the parentheses, and you can just have these empty parentheses, and that will indicate that the method is being called. So yes, in this example, int random number from 1 to 10 doesn't need an input because you don't necessarily need to input anything to get a random number from 1 to 10. So when you call this, you would just say random 1 to 10 parentheses, and you would get a random number from 1 to 10. And then just like any other block of code that we've used, like our if-else statements, our for loops, and our while loops, we need curly brackets to kind of box in where this method begins and ends. So anything that is within the curly brackets is only inside this method. So that's kind of goes back to what we've been talking about the scope of like variables. So anything created within this method is only going to be within this method unless it is returned outside of the method. So this is what we refer to as the body of the method. And then, like I just mentioned about return statements, return is how anything kind of escapes this method. And so um, return can be a value like 4, and that would be like a fixed value, or it can be a variable. So let's say you take in a parameter and you do some kind of um, function or transformation on it and then return it. That would be an example where you're returning a variable like x. You can also return an expression. So maybe instead of doing those steps previously, you just put it all in your return statement. You say return 4 plus 3 minus x. Or if the return type of your method is void, then you're not returning anything, but you still need to say return to indicate that you're exiting the method. So a little more on return statements. You can have multiple return statements if you have like an if-else, for example. You might have different cases where different things return, but only one will be executed because your method will exit and stop as soon as it reaches a return statement. And then basically, a return statement is the only way for information to exit this method. Like I said with the scope, um, because most things will be scoped inside of this method, return statement is how you get anything outside of the method. And now for kind of a quick sidebar explanation of what returning is. So I know it can be a little bit abstract when I'm just talking about it, but we'll kind of go into an example here. So let's say that we have this like mystery machine, and this is representing our method that we're writing. The parameters is like the input of the mystery machine, and the return value is like the output of the mystery machine. So let's say here that the input is hello. It goes into our method or the mystery machine, and the output is hello but reversed. So this is what kind of the code would look like for doing that. And as you can see, in our declaration of the method, we have public, so this is accessible anywhere, string, which means the return type that we're expecting is a string. And that makes sense given what we saw as the output, because that's a string starting with an exclamation mark and ending with that capital H. And then we have mystery machine, which is the name of our method. And then we have string input, which indicates that we are expecting our parameter to be a string, and we're going to reference it using the name input within this method. So as you can see within the method, we declare a string output, and we use the input to define what that output will be. And then at the end, we have two choices. We have choice A, which is system.out.println output. So that's something we've seen a lot, is that print statement. And then choice B, we have return output. So what really is the difference between those two? Well, printing a value is not the same thing as returning it. I know this can be a little bit confusing because both ways are kind of ways to express the output, but what returning a value does is it allows us to use that value later on in our code. So we can set a variable equal to the return value and we can use it somewhere else. Printing it just sends it to the console, but it's not saving it as a variable or saving it somewhere else to be used later in our code. So it's a pretty big distinction, and returning is usually going to be the more helpful one. So um, here would be an example of how we use this method in our main method. So let's say we're using the scanner to get input from the user. So string first word is in.next, so that will be the word that the user inputs. And then we'll call our mystery machine method on the first word. So um, right now, it just says mystery machine first word. And it calls that method, but we're not storing that output anywhere. So how can we access that? The way we just had it, we actually couldn't reference that. What we need to do is declare a variable and set it equal to the output from our mystery machine function. So string reversed first equals mystery machine first word. And so that way our output or our return value from the mystery machine method will be stored as reversed first.
So, you might be wondering how that previous code works. Well, the secret is returning. So, let's say we made the mystery machine method without a return statement. We'd still have this input hello because we have the parameter, and we'd have a method. And that method would know the parameter hello, and it would reverse it. And like in the previous code, we had the option for printing it. So it would print like the reversed hello to the screen, and so the user would see it. But after it got printed, we would have no way to access that value. And like one thing that means is whenever your method, its return value is void, you have to put that call to that method all by itself. We couldn't do what was on this slide, like string reversed first equals mystery machine first word. We would have to have mystery machine all by itself, like mystery machine first word all by itself on one line. Just because it's void, it doesn't return anything. And so, like if we tried to write this, would be returning for reversed first equals nothing because mystery machine didn't return anything. So that wouldn't make sense. Um, and like we want to access the reversed string, so like maybe we could print it more times, or like do something else silly to it. Maybe make it all uppercase, or I don't know, whatever you want to do. So yeah, that's what would happen if we just printed it, didn't return it. Yep, it would just go away, missing. Oh man. But if we have a return statement, hello would still be the input, obviously. The method would have access to hello, be able to change that, and then it would output hello backwards. And we would able to use that return value, assign it to a variable, print it however many times we want outside of the method, all that good stuff. We do need to make sure to capture the return value though. So, assuming we're using the returning version of Mystery Machine, if I just put like Mystery Machine hello all by itself on one line, um, then it wouldn't even do anything. Like Java would like actually go through the method of mystery machine. It would return the reversed hello, but we wouldn't store it, so we couldn't be able to use that value later. And like as far as the user would know, we might as well have not even called mystery machine because we didn't store the value. There's no way to even tell that like we run it based on like the value used. that's like exist in, let's say we were calling it in main. So yeah, just make sure you capture the return value if you want to use whatever your method returned later on. And now, something very important, the call stack, which I say this is extra important for understanding recursion, which is in the next module. And we'll have a little review of the call stack in the next module. Not like necessarily required, but it's in the textbook, and I think it's really helpful for understanding how methods and especially recursion work. So, what is the stack? It's a data structure or just a way of storing data that stores information in a last in, first out technique. You'll get a lot more detail about stack and other data structures in I guess it's 2407 now. But I hate the new course code, so it's still 247 to me. Um, but yeah, and so specifically when we say the call stack, we're using a stack data structure to keep track of which methods have been called, and like which methods are currently executing and the data within those methods. So how can we keep track of that information? Well, we have our call stack, right? We create what's called a stack frame, or kind of like a data entry for each method call when it is once we call a method, and then we place it on the call stack. And you can think of it. The reason we have like the stack of cups is so you put the first cup on the bottom, right? And that's like one method call. And then let's say within that method call, we call a bunch more methods. So each method, one after the other, would be added to that stack of cups until, say, you get to like one method that doesn't call another method. Well, once that method is finished, we take that cup off the top and we'd go be able to like continue working on the previous method. Um, and so yeah, that's what it means by last in, first out. The cup we put on the top is the first one we're taking off whenever that method call is completed. And so it's a little abstract right now. We'll go through like a concrete example to make sure everything makes a little more sense. So we have a fun little silly method. So public static string, my silly method, takes int x as a parameter, and it just adds a smiley face to a string. And it adds x number of smiley faces. Cool stuff, and of course it returns result. So if let's say I'm in main, and I call my silly method with x being our parameter x being 4. Well then, during like before line 1, our call stack is empty, right? But then during line 1, I create a stack frame, which has my silly method, so we can identify the method, and then also the parameter that we call the method with. Great. So that's at the bottom of our stack. Cool stuff. And so the above method is going to execute, and anything created in this method, so for instance, string result, will be created on that stack frame. So after this is like the line 2 within my silly method. So once string result is created, like I just said, it's on the stack frame now. And now we can go ahead and go to where it's actually putting all the stuff into that string result. So now we have 4 smiley faces in string result, and that got updated on the stack frame. Makes sense. And then, okay. All right, and then we're going to call this line 4. And so we're calling mystery machine with result. So basically, we'll be adding on the result of mystery machine, or adding on what mystery machine returns to result. So it'll be 4 smiley faces, and then we'd expect like 4 reverse smiley faces, right? And so we can see once we've called, like during this line 4, we make a new stack frame to represent the new method that we just called. And of course we called it with like 4 smiley, like the string result. So that's 4 smiley faces. Awesome. And then we go on to, here's just a reminder of what the mystery machine code looked like. And so yeah, we have our output, and then we just add the reversed string onto that output and return the reverse string, right? And so now we have after line 1, which is after the for loop, we now have a string output, which is just the reversed smiley faces, right? Since we created that variable within this method. And then after line 2, well, we returned output, right? And so call stack now, we popped off mystery machine from the call stack, And now we don't see mystery machine anymore on our call stack. But we have output returned, and we are going to be adding that to result. But yeah, why was mystery machine removed from the call stack? Well, the method returned, and so it's done executing, and so we take that off the call stack because we finished doing that step. And so now we are going back to the previous method in the call stack, which is, of course, the method that called mystery machine, which obviously silly method. All right, so now we're back in silly method, and now result takes what mystery method returned, which is just the reverse smiley faces, and concatenates that onto the previous value of result. So now result is four forward smiley faces and four reverse smiley faces. All right. And that's just what the call stack looks like. And then after line 5, we'll return like the result string, which four forward smiley faces, four backward smiley faces, and then we finished. We returned a value. So now our call stack, we take my silly method off the call stack. Now our call stack's empty, basically. And now we finally finished line 1, and so this call for my silly method would just have that like final result string. And as you can see, this line technically doesn't store that anywhere, but if we wanted to actually use the value we just created, we would need to store that. But this is just an example to show how the call stack works. All right, so just to recap, definition. So our call stack's just a strategy to keep track of every method that has been called and the variables created during the method's execution. That's just how we know like what's going on, in the method, like all the data that we're needing. And then why do we even have the call stack? What's the point? Well, we want to maintain storage while also knowing in the program's execution we are. So we know what data the method has and where we are in the execution. Like once one method finishes, how do we know where to like go next in our code? And we'll get a lot more on call stack. I think call stack's very useful for like the next module. Like I think call stack's what's very useful for making like recursion click and like making recursion make sense. So I'd say definitely spend some time thinking about the call stack. And like I think I might put like another video just so you have like an extra explanation of the call stack in like the comments and the notes for this slide. But yeah, just like I'd spend a lot of time thinking about the call stack. In addition to like make sure you know how to write a method. I'd say those are like two most important things. Like just being comfortable writing a method and know like how um, like the order of execution and the data for each method is stored. All right, and then this is a bit of a side note. We won't use this as often, but obviously still important to know. I think we alluded to earlier that you can have multiple methods with the same name. So let's say I tried to have these two methods, public static string, my method int x, and public static int, my method int x. So do you think we could have like both of these methods in like the same class? Give you a second to think, just like a guess. Well, unfortunately, I don't know if what your guess was, but we won't be able to make these two methods because Java's going to think of them pretty much the same. Because when I call my method with parameters with the parameter 4, I don't know which method I'm trying to use. Java can't tell like which method you're trying to use. Like, should I run the one that returns string or the one that returns int? So basically, we just need to make it so that our method, like whenever we call the method, Java can tell which one it's supposed to use. So how about this example? Public static string, my method int x, and public static string, my method string x. Well, they have different parameters, so whenever you run them, Java could see, oh, you're running them with either an int, I use the int one, or a string, I use the string one. And so that's totally chill. Uh, and yeah, so obviously we can see my method 4 has to be the int one, my method hello has to be the string one. All right. What about public static string, my method string y, and public static string, my method string x? Take a second, guess, what do you think Java would allow you to have both these methods? And if you want to just see for yourself, I always like experimenting with this stuff by myself if I'm not sure. Go ahead and you can type it into VS Code and see whether or not it'll let you do this. So Pause. Three, two, one. All right, here's the answer. You can't have both of these method headers because um, like the name of the parameter, it's just temporary. Like it's really just a placeholder. And like whenever you call the method, that parameter, it's only going to exist inside of that method. And so it doesn't really matter what the parameter's name. Because like whenever you have the method call, like you're still going to write my method and then some string, right? And so whenever you're writing that method call, Java can't tell like whether you'd want that string to be named Y or X. Like the method call would look exactly the same. So just to like have a little like neat little summary to describe that. So the parts of the header that make the method unique are determined if you can call the two methods and be sure which one you're calling. So basically the parameter types have to be different or in a different order. That's totally fine. Like if I had my method int x, string x as my parameter, or string xy as my parameter, and then another method, my method string xy int x. That'd be fine because they're in a different order, and Java could tell, oh, you have int then string, that's one method. You have string then int, that's another method. Cool. And then here are just some problems you can try on your own just to get some extra practice with methods. Obviously, there's some exercises in the exercise repo, but in case you want some additional practice, just choose a few of these that sound interesting to you. So you could write a method to calculate the area of a right triangle, say given like the coordinates of some points, or like convert, say your parameters degrees, convert that to radians, or given two integers, return whether the second integer evenly divides the first. Two angles of a triangle, return like what the third remaining angle is. And then I'd say this one's pretty useful just because working with methods and arrays as parameters or return types can be tricky. But you can use arrays. I think we talked about this earlier, but very similar, basically the same as to how you would use arrays with like any method, parameter, or return value. So yeah, just reverse the elements in the array, return the nth even number, and then another challenge, which I think is a good practice. Make a copy of your cookie clicker assignment and rewrite it with methods. Might just make things more kind of like compartmentalized. Some like slightly easier to read code too, because you can just look at the method name and see like, oh, this part's doing that. So yeah, just make your cookie clicker assignment a little neater using methods. All right. So what's next? I mentioned this earlier, but recursion, the best module, but also pretty widely agreed to be the most difficult module. So yeah, please don't miss Studio next week. It'll really help you with the hardest concept we learn. I'd say also make sure you attend Studio this week because methods are very integral to doing recursion. You can't have recursion without methods. So just make sure you attend Studio. I'd say the next two studios probably some of the most important. And then obviously Module 5 quiz on Monday, and Assignment 5 expected next Wednesday. And I'd also strongly recommend that you complete this assignment because Assignment 8 builds off of it. I mean, you can complete Assignment 8 without doing Assignment 5, but Assignment 5 just gets you used to like zombies and working with like what we expect you to do for those assignments. So, yeah, I'd strongly recommend doing Assignment 5 so that it's easier to do Assignment 8 later on. But that's all we have for you today. Thank you so much for walking or watching, and let us know or attend office hours if you have any questions about methods. Bye bye.